we're going to talk about the carboxylic acids and derivatives. So we have the following outlines. So first, we'll discuss the properties, followed by the relative reactivities, the reactions that they undergo, as well as the preparation of each of the carboxylic acids and its derivatives. So let's first talk about the properties of your carboxylic acids. So the general structure is given by the following. Now this carbon is sp2 hybridized, and the different groups that are attached to your carboxylic acids actually affect its acidity. Now, since your carboxylic acid contains a hydroxyl group, itong portion na to, so it has a hydrogen that is directly attached to an electronegative atom, which is oxygen. Hence, it is capable of forming H bonds. So it's an H bond donor, and at the same time, it's an H bond acceptor. So tignan natin. So for example, you have here two carboxylic acids. So itong portion na to, ayan. So it's H bond donor, tapos this one is an H bond acceptor. And then if you have another carboxylic acid, pwede pa din siyang mag-donate ng hydrogen bonds, tapos another oxygen can come into contact and form another H bonding. And because of this H bonding, we expect that your carboxylic acids have relatively higher boiling points compared to their ester or their ketone or aldehyde counterparts, primarily because they are capable of donating and accepting H bonding. And kung i-compare natin yung the same number of carbons ng alcohol, ito, at saka carboxylic acids, we expect that your carboxylic acids will still have a higher boiling point. Kasi nga, dalawa yung kanyang H bonds, isang acceptor and isang donor. Now, kung titingnan natin, no, yung relative boiling points, so the highest boiling point is that of the amide, next is the carboxylic acid, followed by the nitrile, and then ester, acyl halide, and then ketones and aldehydes. So, ito yung general trends. Yung responsible para sa trend na to is that of your hydrogen bonding. So, for example, this one, yung inyong ester, ayan, mababa lang yung kanyang boiling point kasi it's only an H bond acceptor and it is not capable of forming H bond within itself. And in the same manner, ganun din itong acyl halide, yung inyong ketone, aldehyde, ether actually, isa pa yan na H bond acceptor lang din. And it's not capable of forming H bonds ng parehong molecule. So, unlike your carboxylic acids, ayan, so capable naman sila of forming H bonds. Now, why is it that your amide is having a higher boiling point than your carboxylic acids? Now, the answer lies again with H bonds. Kasi kung titignan ninyo dito, okay, dalawa yung hydrogen niya na kayang ibigay. And at the same time, meron ka ding acceptor na C double bond O. Ito, yung oxygen na yan, yung carbonyl oxygen, it can accept a hydrogen. Another factor which affects the higher boiling point of your amide is its resonance structure. So, tignan natin yung resonance structure ng amide. So, when we draw that resonance structure, ganito yung mangyayari. Now, since your nitrogen is less electronegative than your oxygen, so ibig sabihin, mas malaki yung portion na kino-contribute ng resonance structure na ito versus dun sa inyong carboxylic acid. Kasi kapag ka nagkaroon ng resonance structure, yung inyong carboxylic acids, ganito yung magiging itsura niya. Ayan. So, magkakaroon ka ng positive charge sa oxygen. Since your oxygen is more electronegative, so itong resonance structure na to, mababa lang yung kinocontribute niya dun sa resonance hybrid. Kasi nga, yung positive charge, hindi niya kayang i-carry versus that of your nitrogen na less electronegative. So, kung merong considerable amounts ng ganitong resonance structure, itong sa amide, makikita nyo yung dipole moments, no? So, you have your negative charge and you have your positive charge, which then contributes to higher intermolecular forces of attraction and hence a higher boiling point versus that of the carboxylic acid counterpart. Now, just like any other acids, your carboxylic acids are acids. Hence, they are capable of reacting with bases to form salts. So, for example, you have your carboxylic acid plus a base. You will form salt and water. So, the question now is, if they are acids, what are the different factors which affect the acidity of your carboxylic acids? So, let's take a look at the different substituents that can be attached to this group to increase or decrease the acidity of your carboxylic acids. The first factor is the presence of electron withdrawing groups. So, kung makikita nyo dun sa example natin na sa taas, so, yung presence ng hydroxyl group at saka yung presence ng halides dun sa proximity ng carboxylic acid group increases the acidity. Now, between your oxygen and your fluorine, ang halides or fluoride, your fluoride or other halides are more electron withdrawing or electronegative versus that of oxygen. So, mas mataas yung pull niya ng electrons away from the carboxylic acid moiety. So, ano nangyayari? If yung electrons mo is being pulled dyan, so ito, yung density ng electrons, syempre, papunta dyan sa electron withdrawing group. So, ano nangyayari? Yung bond mo between your oxygen and your hydrogen weakens. Ito. Kaya, mas madaling ma-release ngayon sa solution yung hydrogen, making it more acidic. Another is the proximity of the electron withdrawing group doon sa inyong carboxylic acid moiety. So, ito, mas malayo siya versus here, and of course, dito sa pangatlo nating example, making the acidity increase from left to right. So, pag mas malapit yung electron withdrawing group doon sa inyong carboxylic acid moiety, mas acidic. Now, let's talk about the relative reactivities of the different carbonyl compounds. So, the most reactive is your acyl halide, and the least reactive is the carboxylate ion. So, ibig sabihin, ang sinasabi nitong reactivity series na to, you can create or you can synthesize acid anhydride from acyl halide. You can synthesize aldehyde from acid anhydride. You can synthesize a ketone or an ester or a carboxylic acid from that of the more reactive compound in the reactivity series. So, ibig sabihin, hindi ako madadalian or hindi ako makakapag-produce, for example, ng acyl halide from an amide. Mahirap mangyari yun. Kasi meron tayong sinusunod na reactivity series. Now, in the reaction ng inyong carboxylic acid derivatives, it follows the substitution reaction. Unlike your ketone and aldehyde, di ba, addition yung kanilang ina-undergo. Now, Ito, yung chloride, yung carboxylate, hydroxyl group, alkoxide, and you have your amine. Ayan. They are poor living groups. However, dito sa reaction na ito, ayan, pwede silang maging living groups primarily because the attack of the nucleophile doon sa inyong partially positive na carbon, yun yung rate limiting step. Now, based dun sa reaction mechanism, it is the attack of the nucleophilic species towards the partial positive carbon. So, ibig sabihin, anything that can increase the partial positive charge in the carbonyl carbon increases also the reaction rate. And at the same time, basta ma-expose mo yung carbonyl carbon dun sa nucleophile mo, mas mabilis din yung reaction. So, ano yun? So, number 1, you have your steric effects, which can affect the reactivity of your carbonyl carbon or your carboxylic acid derivative towards the nucleophilic attack. So, syempre, kung naharangan yung carbonyl carbon mo, kung yung R group mo ay bulky, mas magiging mabagal yung reaction. Number 2 is the electron withdrawing group. Kagaya ng nabanggit natin kanina, kung magiging mas positive yung inyong carbonyl carbon, mas magiging attractive siya for the nucleophile. So, ibig sabihin, mas mabilis din yung reaction. So, ibig sabihin, the presence of your halides, for example, fluorine, chlorine, bromine, and iodine, they increase the acidity of your or the reactivity rather of your carbonyl carbon, and ano pa, resonance. Of course, kung stable ang inyong carbonyl carbon, hindi yun mag-react by virtue of having resonance structures. So, para ma-demonstrate natin to, let's take a look at the following examples. So, tignan natin, no? Given dito yung different compounds. So, punta muna tayo sa letter B kasi yun yung pinakamadali. So, because of the presence of your fluoride, which is electron withdrawing, ayan, yung partial positivity ng carbonyl carbon nag-i-increase din. Hence, mas mabilis siya mag-react towards a nucleophile versus yung wala kang electron withdrawing group. Now, between the two compounds, ito sa letter C, sino kaya dyan ang merong mas mabilis na reaction? Definitely, ang magkakaroon ng mabilis na reaction is your substituted to the para position ng nitro. Kasi ano bang ginagawa ng nitro? Your nitro has the following structure. Diba? Ngayon, since it has a partial positive charge, ito, meron siyang positive charge rather, hihilahin niya ngayon yung electrons, which makes your carbonyl carbon more positive versus yung inyong carbonyl carbon na directly attached doon sa inyong ring. Kasi, anong ginagawa niyan? Actually, it lessens the positivity ng inyong carbonyl carbon dyan kasi pwedeng magkaroon ng resonance. Ayan. Now, punta tayo sa letter A. This one is tricky. Kasi between the two, sino ang mas mabilis mag-react sa nucleophilic substitution? The answer is ito, yung nasa right na compound. Bakit? Kasi the presence of your methyl groups here and here makes the carbonyl carbon to be out of plane doon sa ring. So, ibig sabihin, hindi rin magkakaroon ng resonance or mahihirapan na magkaroon ng resonance structure towards the carbonyl carbon kasi natitwist yung plane. So, nawawala siya dun sa planarity. So, a while back, we discussed that there's a reactivity series. So, ngayon, hindi ka pwede na makabuo or mahihirapan kang makabuo ng isang derivative from a lower reactivity papuntang higher reactivity. So, yun yung gagamitin nating principle para masagot tong problem na to. So, for example, in number 1, so you have an acid anhydride here and yung product mo is an ester and the carboxylic acid. So, ang nafe-favor dito is yung inyong products kasi mas less reactive versus that of the acid anhydride. Ito naman, tignan natin. So here, we have an amide and then we have an ester. So between the two, okay, mas reactive yung ester versus that of an amide. Hence, ang ma-favor ay itong inyong reactants. And then sa letter C, ayan, ang inyong product is an amide and ang inyong reactant is an acyl halide, which is more reactive. So, ang ma-favor ay itong products.